the signal. Now let's look at what happens with sampling over time. And we show here that we have three different AC waveforms, a fairly slow one, an intermediate speed, and a little bit faster one. And we sample those signals at the same rate, 10 samples. And we see then that, we capture the outputs of those signals. And these signals were somewhat carefully chosen. But if we then look at what we call the reconstruction of that, we find that these effective output signals, if we were to put this then through a D to A converter, they would all look the same. So that looks pretty good for the slow speed signal, but it turns out that that output also looks the same for the higher speed signals. We have lost information from those higher speed signals. We're okay on the low speed signal, but we've lost a lot of information because we did not sample often enough. Now, this has been turned into a theory developed by a Swedish fellow named Harry Nyquist, who developed this theory in the mid-20s when he worked for Bell Labs. And essentially, the theory is that you need to sample a signal with a sampling rate at least twice the maximum frequency of information that you're trying to capture from that signal. So roughly speaking, if we consider an audio signal, which we normally would cap off at about 20 kilohertz, and because our ears don't work very well after that, most audio is capped at or filtered down to 20 kilohertz. You need to sample that signal, audio signal, at 40 kilohertz to be sure that you're getting all of the information that's in that signal. And in fact, CDs are sampled at 44 kilohertz, a little bit higher to accommodate the filters. But it's and that theory it works on no end of electronic systems.